Alright guys, so my name's Kazema and I'm one of Mr. Tucker's kids this year in 2016. And the topic I want to help you guys with is integral test and P-series. And Mr. Tucker, just for you, there's my name right there if you didn't catch my name before. So in case you need it, there it is. Alright guys, so I know that the integral test and just series itself can be a little bit confusing, so this video should be able to clear some things up about the integral test and just P-series in general, but if not, then you always have Mr. Tucker and just ask him for any help that you need. Alright, so let's move on. So before we go into looking at what the integral test really is, let's just make sure that we know what series actually are. So this little sign, this little backwards 3 that has these straight lines, that is called a backwards 3 to me because the name escapes me right now. But looking at that sign essentially looks like a big plus. Because you see, if we look at it, we could take each of these 4 lines, forget these little dashed lines right here, but we can take these 4 lines, this 1, 2, 3, 4, and we could turn that into a big plus. So we take this little one, and we take this one, and we combine them, and we make that the 2 sides of the plus, right there. And we take this one, and this one, and we make that the top and the bottom of the plus. So now, when you look at it, I want you to remember that this sign always means a big plus. So whatever equation, whatever magical mess is after this sign, no matter how confusing it is, no matter what the symbols are on the top and bottom, just remember that all you're doing is you're adding them up. Just like that plus right there. That plus is that. So just remember that as we go on, okay? So now, you look at a series of sequences, you can watch the other videos to learn more about those. But now let's see. So we have integral sign, and we have this backwards 3 sign. I think you guys know the name more than me. You guys probably know more than me already. But looking at that, so when we look at this sign and we look at this integral sign, how do these two relate to each other? Right? I mean, you guys who took pre-cal 2 years ago or 1 year ago, you've seen how you could take equations like this and turn it into integrals. But what does it really mean? So guys, I'm sorry I don't have graphs for you today, but looking at this, basically these mean the same thing. Is with the integral, you add up the area under a curve, and you add up all the little individual rectangles, all the individual parts. And then with this sum, you add up each individual number that you get. And the only difference is that while the integral is all the little decimal places, the 1.1s, 1.2, 1.35s, all the little numbers everywhere, this backwards 3 symbol only adds up the whole numbers. So if we're going from like n equals 1 to 2, and we had the equation n, we would plug in 1, and that would give us a 1. And then we want to add the next number, and that next number is 2, which is the last number. And we plug the 2 in, we get 2, and that gives us a 3. Alright, so that little messed up 3 right there, that's a 3 by the way. That's our answer. Now this integral is the same thing, except now we went from 1 to 2, and we had x as our equation. We would have to anti-integrate that, and we would basically add up all the numbers from 1 to 1.2, making their little rectangles and their little concepts and finding the whole integral. Alright, so that's just like a basic concept. So this notation and this notation are essentially the same thing, because what you're doing is you're adding the area and you're adding the numbers under each curve in a sense. So these two are alike, and these two could help you with that. So now, since we know that this relates to this, one of our tests, which is the integral test in this case, we could use that test to see if something's convergent or not. Just like before, last semester you learned how there were functions that you could integrate and there were functions that you couldn't integrate. Right? So in that same sense, Alright, but this function has the same purpose as, it's the same purpose in the integral as this function is to this whole backwards 3 notation, this whole backwards 3 concept that we have over here. So if we want to figure out something that's convergent or not, in the same way that a function could be, because function you could integrate it or not integrate it, the same thing would be here. So we can know that a function is convergent or not divergent based on taking the integral of it. So in this case, if the function over here is, if you take the integral of it and as it goes to infinity, if it does not approach 0, then it is not convergent, it is divergent, right? So we have the integral, so let's move on to our first problem. I will get you some practice problems, see if that helps a little bit. So let's look at this first one. So we have the sum is what it's called, not backwards 3, sorry about that. So we have the sum of, from n equals 1 to infinity, of 1 over n. Alright? So in this case, 1 over n is our function. And so now, the first thing we have to do is we have to do the nth term test. So nth term test, we just take the limit as n approaches infinity of the function, which is 1 over n. So as n approaches infinity of 1 over n, we get 0, right? So that's good. We know it passes the nth term test. So now the next way, what we have to do now is we need a test to check for convergence or divergence. So now we could use the integral test, because we know that if we integrate this function right here, 1 over n, and if we go from whatever the bounds of integration are, which it gives us in this sum, so it's from 1 to infinity, if we can integrate those, then, and if the function actually approaches 0 as it approaches infinity, then we know that it's convergent. So let's write it out, see if it makes a little bit more sense. So right here, 1 over n. So now we're going to take the integral of that. So the integral from 1, and let's make b equal to infinity, just to keep that notation. So from 1 to b of 1 over n. Alright? dn. Let's just add that dn in there. So we know that the integral of this, I'm sorry if I'm moving a little bit fast, but the integral of 1 over n is just the natural log of n. Alright, the natural log of the absolute value of n. And we know that we're going from 1 to b. Alright, so we know, so just keep in mind that b is still equal to infinity. So now looking at this, it would be, since we know that b is going to infinity, we would have to do the limit as b approaches infinity, right? Just to keep that weird notation going on, of the natural log of b minus the natural log of 1. Alright? So now looking at that, let's see. So now let's just, so let's see. So what's the natural log of 1? The natural log of 1 is just 0, right? So we get rid of that and just replace it with 0. So now we just have the limit as b approaches infinity of the natural log of b. So now the natural log of infinity is just infinity. Right? So if you take the limit of the natural log as b approaches infinity, you get infinity, you don't get 0. So now, since you cross all this out, you get infinity and not 0, then essentially this is divergent and it doesn't converge. So using the integral test, we found out that since this doesn't have an integral, we know that's divergent. Alright. Yeah, divergent right there, that little messy handwriting. Alright, so we look at this problem, it's more like a coconut. It's like you broke it open, and it was a bad coconut too. You broke it open and you realized that there was no water, the meat inside just smelled nasty, and it just didn't work out. It's divergent. Alright? So that was that. And now since I'm running out of time, we're approaching our 10 minutes, let's go on to p-series. So p-series is just an extension of the integral test as you already learned. And basically, just the number on top, just the number that is going from 1 to over n. So its formula is just 1 over n to the p. So looking at that, this p, when you take the integral of it, when you do the integral test, when you get, if p is less than or equal to 1, then the integral test won't work. And if p is bigger than 1, the integral test will work. Alright, so I want you guys to do these 6 problems here, and then just come up with the answers, and then I'll go over the answers, and then that'll be it. That'll be the end of our video. Alright, so just take a moment, pause the video, and answer the questions, and then I'll go ahead and answer them. Alright, so this first one, 1 over n cubed. So in this case, what's p? P is equal to 3, right? Zoom in a little bit. So p is equal to 3. Alright, so is 3 bigger than or less than 1? 3 is bigger than 1, so no, it's convergent. Next one. So 1 over the cube root of n. Alright, so that's the same thing as saying 1 over n to the 1/3. So in this case, p is equal to 1/3, and since 1/3 is less than 1, we know it's divergent. Alright, so we move on. 1 over n to the 1/2. So p is equal to 1/2, and since 1/2 is less than 1, we know it's divergent. We go down here. And 1 over n to the negative 1. Alright, so we got this weird little notation, but it's okay. So p is equal to negative 1, and negative 1 is less than 1, so it's divergent. And then now 1 over n to the 4/5, p is equal to 4/5, and since 4/5 is less than 1, it's divergent too. And then now 1 over n to the 5/4 is p is equal to 5 over 4, and it's greater than 1, so it's convergent. Alright guys, so here's the answers one more time. But, well, I hope this video helped you, and I hope you do well.